Okay, so what we're doing in today's section is we've got three different things. We're going to be simplifying rational expressions, multiplying rational expressions, and dividing rational expressions. And we're going to kind of split this up into two different videos so it doesn't get super long. But essentially the I can statement is exactly what the title was, is by the end of the section we want to know how to do all three of those things. So as kind of a reminder for you down at the bottom of the page here, sometimes using correct terms can feel confusing. Essentially, a rational expression is something that's written as a fraction. So all of this is basically just simplifying fractions, multiplying fractions, dividing fractions. That's what we're doing in this section. And we're going to start off with simplifying. And simplifying is something we definitely have done before, and so I wasn't going to take too long to go over it, but yet it's something that's important enough that we got to make sure you remember how to do it before we get to the multiplying and dividing. So on the left here, we've got 3x to the 7th over 2x to the 4th. And so we've got a monomial on top and a monomial on bottom. And so everything is technically being multiplied kind of together. It's all one big thing, which means you're allowed to cancel anywhere from top and bottom that we can. So when I look at this one, I see the x to the 7th and the x to the 4th. They both, they're like terms, so they can reduce. Now there's different ways to say this or express this. In my mind, the way that I think about it is that I can take away 4 x's on top and bottom. And like I said, there's different ways to express this, but if I take away 4 of them from the top, I'll be left with 3. And then the 3 and the 2, the regular numbers, they don't have any kind of common multipliers that can reduce out. So this one would be simplified down by just taking out those x's. There's two different ways we can write it. One way we can write it is 3 halves times x to the 3rd. The other way would be 3x to the 3rd over 2. And they both say the exact same thing. It's just kind of your own personal preference. Now, the other thing that's in the directions that I kind of skipped over there is it's going to be important that we learn how to identify numbers that we can't use. I mean, the real term is a domain restriction. But so, like, say we look at this answer, the 3 halves x to the 3rd. Technically, no matter what number we put in place of x, we'd get an answer. But the problem comes in that in the original problem, before we simplified it, we wouldn't be allowed to use x equals 0, because then it would become 2 times 0 to the 4th on the denominator. So what we would do is we would say, these are the answers, but then the x value that would be undefined would be x equals 0. So we would say x cannot be 0. So that's kind of like the way that we'll phrase it. Okay, so then we look at the problem on the right, B. Got x squared minus 2x minus 3 over x squared plus 5x plus 4. And if this looks familiar to you, that's because we used to do it quite a bit in the factoring chapter. So a lot of the factoring is kind of supposed to be somewhat, you're supposed to remember how to do all of it. So I won't usually necessarily go over how to factor again. But absolutely, if you need some more help with factoring, that's something you can ask me, or you could try to look up factoring videos as well. So the top of this fraction anyway is I'm going to be factoring this. There's no number on the x squared, so that means these are what I call FOIL factors. And I'm going to have x and x, and I'm going to look for what multiplies a negative 3, adds to negative 2, would be negative 3 plus 1. On the denominator, I've got x squared plus 5x plus 4, and the two numbers that multiply to 4, they add to 5 are 4 and 1. So I've got plus and plus for all of that. Now between the top and the bottom, now that everything is written as multipliers, I can cancel. I cannot cancel, I'll write this, but I'll erase it right away. The most common mistake I see is somebody would try to cancel off these two things because they're both x squareds. But that doesn't work at all because they're both being added or subtracted. So the only time you can cancel is when things are being multiplied. And I do have an x plus 1 on the top and bottom that I can cancel out. And my reduced simplified answer would be x minus 3 over x plus 4. And you don't need the parentheses. I just basically wrote them out of habit, but so you can write it with or without. And then I will also look for what numbers shouldn't be possible to be used. So any numbers that would make this undefined. And the easiest place to look for that is the factors. So I'm going to look at the x plus 4 and the x plus 1. And I'm specifically going to look at the factors before I simplified. So both of these are where I'm going to get my undefined values from. And the easiest way to do it is you're going to set them both equal to 0. And then this gives me the x values that I wouldn't be allowed to use because it would give me a divided by 0. So when I solve both of those, I get two different x values. And so then that tells me x cannot be -4 and -1. Those are the undefined values. All right. So here, I've got a problem for you guys to try that is similar to what we just did. Why don't you pause the video here, try it on your own, and then I've got the answers on the next page where you could pause it again and kind of look over your answers. So here we go. The question on the left, when you simplified it down, you should get 2x to the 9th, and x cannot be 0. Now the only main difference I see on this question than the one we did together was the fact that the regular numbers simplify down. So 8 goes into 16 twice, and 8 goes into 8 once, so then that reduces or cancels down. On the right-hand side, this is somewhat similar to the one we did, except for the numerator doesn't have as many factors. And the hardest part to remember is when you cancel factors and it looks like nothing is left on top, don't forget that canceling is actually not even really a good term. It reduces down, so it simplifies. So what I did do is I divided top and bottom by 3x plus 4, and I got an answer of 1 and 1. So the top of the fraction would still have 1. Okay, let's move on to the another example. So today's video is just the simplifying part. We're going to do multiplying and dividing in the next video. The only reason I wanted another example for simplifying is because you often can run into examples where the factors look like they don't cancel each other out, but essentially they do. Terrible way to say that. I got to work on my phrasing. So let me factor everything first here. So top of this fraction, I can take an x out, and so they had a common factor of an x. I'd be left with 2 minus x. Bottom of the fraction, it looks like I can factor minus 2 plus 1 would give me the correct information. So let me rewrite this here. So I've got x times 2 minus x on the top. On the bottom, I've got x minus 2 and x plus 1. Well, obviously the x and the x plus 1 aren't really going to be part of any of this canceling or reducing because they don't have anything in common. But what does happen is if you have factors that are reversed from each other, so 2 minus x, x minus 2, they can cancel. And then what happens is you leave a -1. And you can write a -1 on the top or the bottom, kind of whatever makes you feel more comfortable. And there's a couple different ways I could explain this if you want me to. Over on the left here, I'm going to write down 2 minus x. Let's think of 2 minus x as almost like the answer. If I took -1 times x minus 2, I would get -1x plus 2. But nobody would write -1x plus 2. They would write 2 minus x. And so it feels kind of strange to say that 2 minus x and x minus 2 are related. But what you do is you factor out a -1 almost. So when we cancel and reduce these out, you're going to leave a -1. And that's only when factors are reversed. So this final answer, when simplified, I have on the top I have an x times a -1. So I'd have -1x or negative x. On the bottom, I've got an x plus 1. And then if I didn't write it in the directions, but if I'm still trying to practice looking for what values are undefined, I would look to the original problem before simplified, and I'd set each one of these equal to 0. And then those would be my undefined values. So x cannot be 2 and -1. And then I've got a problem for you guys to try on simplifying again with reversed factors. Okay, if you want to pause it here and try this one, this is what you should get. On the numerator, you can factor out a 2. And then you would get, oh, I shouldn't write that. That looks like a negative sign. You get a 2 times 5 minus x on top. X minus 5 is the only factor on the bottom. These factors are reversed, so it would leave a -1. And it doesn't matter if you write it on top or bottom. What happens is there's no expressions with variables left. You just have numbers. So you'd either have 2 times -1 on top or 2 divided by -1 on bottom, but either way the answer is -2. And then we have to keep in mind that the original question, before we reduced and simplified it, you couldn't use 5, because if I set x minus 5 equal to 0, I get 5 as a number that would make the denominator 0. So I would write the answer as -2, x cannot equal 5. Okay, excellent job. I will make another video on multiplying and dividing so that everything is not too long together. See you in a minute.